If you cannot tell what changed in your AI agent, you cannot safely trust it. Every serious agent needs version control, not just for code, for prompts, tools, policies, data tests, and rollout decisions. Here is one of the most common mistakes I see with AI agents. Someone changes the prompt, then someone adjusts a tool permission, then the model gets swapped, then a retrieval source gets updated, then a policy rule gets rewritten, and suddenly the agent behaves differently. Maybe it skips evidence. Maybe it calls a tool too aggressively. Maybe it summarizes a vulnerability incorrectly. Maybe it stops asking for approval when it should. The team notices the output changed, but nobody can answer the basic operational questions. What changed? Who changed it? Was it tested? Was it approved? Which version was working before? Can we roll back right now? That is the problem this video is about. A production AI agent is not just one prompt sitting in a text box. It is a system, and systems need version control. When people hear version control, they usually think about code. That matters, but with AI agents, the version is bigger than the code. An agent version includes the prompt, the system instructions, the model, the tool list, the tool permissions, the data sources, the retrieval settings, the policy rules, the approval gates, the memory configuration, the evaluation tests, the deployment stage, and the rollback plan. If any of those change, the agent can behave differently. So the first rule is simple. Do not version only the code, version the behavior surface. The behavior surface is everything that can change what the agent sees, decides, or does. If it can affect an action, it belongs in the version record. The obvious place to start is prompts. Every production prompt should have a version number. It should have an owner. It should have a change note, and it should be tied to tests. Do not just overwrite the prompt and hope everyone remembers what happened. Save the old version, save the new version, write what changed. For example, maybe version 1 said summarize every vulnerability finding. Version 2 says summarize every vulnerability finding, but separate confirmed evidence from assumptions. That is not a small wording change. That changes behavior. It changes what the agent is allowed to present as fact. So the change note should say that the best prompt version records are boring and specific. Changed evidence language. Added approval requirement. Removed unsupported claim pattern. Tightened escalation rule. Reduced output length. A prompt diff should make the operational impact clear, not just the text difference, the behavior difference. The next thing to version is tool access. Tool access is where AI agents become operationally risky. A chatbot that writes text is one thing. An agent that can send messages, modify tickets, query systems, create reports, or trigger workflows is different. So every tool permission needs to be part of the version. Which tools can the agent call? Which actions are read only? Which actions require approval? Which actions are blocked? Which environments can it touch? Which accounts or projects are in scope? Tool permission change should never be invisible. If yesterday the agent could only draft a Jira ticket, and today it can create the ticket automatically, that is a release. If yesterday the agent could read scanner results, and today it can suppress findings, that is a major release. Treat permission changes like production changes. They need review. They need testing. They need a rollback path. Data sources also need version control. A lot of agent behavior changes are really data changes. The prompt did not change. The model did not change. But the agent started using a different knowledge base, or a new policy document, or a new scanner feed, or a different retrieval threshold, or a stale cache. Now the answer changes, and everyone blames the model. For production agents, track the data context. Which sources are enabled? When were they updated? Which retrieval settings are active? What documents are considered authoritative? What sources are advisory only? This matters a lot in cybersecurity. If a vulnerability triage agent pulls from scanner data, asset inventory, threat intel, and policy exceptions, you need to know which source won when they disagreed. The version record should make that visible. Official source, fallback source, advisory source, ignored source. If the source hierarchy changes, the agent version changed. Policies and approval rules are another part of the agent version. This is where teams often create accidental drift. They start with strict approval gates. then they relax one rule, then they add an exception, then they remove a human review step because the agent has been working well. Each change might make sense in isolation, but together they can change the risk profile of the whole system. So approval policy needs a version. When does the agent need a human? What actions are always approval gated? What confidence threshold is required? What stop conditions pause the agent? What blast radius is allowed? What user group is in scope? What happens when policy and speed conflict? If you cannot point to the active approval policy, you cannot prove the agent is operating under the right boundary. And if you cannot prove the boundary you are guessing, a version is not complete until it has tests. For agents, tests are not only unit tests. They include evaluation cases. Golden examples, bad examples, cases. Regression cases from past failures, tool call simulations, approval gate checks, and rollback drills. Before promoting a new agent version, ask a simple question. What did this version prove? Did it pass the known failure cases? Did it handle messy input? Did it refuse unsafe actions? Did it ask for approval at the right time? Did it preserve the audit trail? Did it produce better outcomes than the previous version? If the answer is unclear, do not promote it. The tests are what separate controlled improvement from random prompt tweaking. Every incident should create a new regression case. Every major behavior change should have a before and after comparison. And every production version should have evidence attached to it. Once you have versions, you need release notes. This does not have to be complicated. A good agent release note can be short. Version number, date, owner, summary of changes, risk level, test pass, approval status, rollout stage, rollback target. That last one matters. Every release should say which version you go back to if something breaks. If a new prompt improves summaries but weakens evidence handling, you should know the last known good version immediately. Do not wait until an incident to figure that out. The release note is also where approval becomes visible. Who reviewed the change? Was security involved? Was the workflow owner involved? Was the business owner involved? For low risk internal drafting, the approval might be lightweight. For an agent that can touch security tickets or operational workflows, the approval should be stricter. The point is not bureaucracy. The point is traceability. Version control only matters if rollback is real. A lot of teams say they can roll back an agent, but when something fails, they realize the old prompt is gone. The old model setting is unknown. The old retrieval source changed. The old permission set was not saved. And nobody knows which version was actually running. That is not rollback. That is panic. A real rollback plan includes the complete last known good agent version, prompt, model, tools, permissions, data source, policies, tests, deployment stage, and owner. If the current version fails, you should be able to pause the agent, restore the last known good configuration, and verify the system is back inside its safe boundary. Rollback should be practiced before you need it, not invented during the incident. Let me make this concrete with a cybersecurity example. Imagine you have a vulnerability TRIAGE agent. Version 1 reads scanner findings and drafts a TRIAGE summary. It is read-only. It cannot modify tickets. It cannot suppress findings. It must cite scanner evidence and asset criticality. Version 2 adds threat intel context. Now the agent can say whether a CVE is actively exploited. That means the data source version matters. Which threat intel feeds are enabled. Which one is authoritative. How fresh does the data need to be. Version 3 adds ticket updates. Now the agent can move a ticket from new to needs review, but only after human approval. That means tool permissions and approval gates changed. Version 4 allows automatic low risk tagging. Now the agent can tag informational findings without approval. That means the blast radius changed. Each version is not just a better prompt. It is a different operating boundary. If a finding gets mislabeled, you need to know which version did it, what data it used, what rule allowed it, and whether the previous version would have handled it correctly. That is why version control is not optional for production agents. It is how you explain behavior, it is how you improve safely, and it is how you recover when something goes wrong. Here is the practical checklist. 1. Version the full behavior surface, not just the code. 2. Save prompt and system instruction diffs. 3. Track model and configuration changes. 4. Version tool permissions and approval gates. 5. Track data sources, retrieval settings, and source authority. 6. Attach tests, evals, and golden cases to every release. 7. Write simple release notes. 8. Define the rollback target before launch. 9. Keep a last known good version ready. And 10. Treat every production change like a controlled release. The big idea is simple. An AI agent does not become trustworthy because the latest demo looks good. It becomes trustworthy when you can explain what changed, prove what passed, control what it can do, and roll back when needed. That is version control for AI agents. If you are building AI agents for cybersecurity, automation, or real business workflows, subscribe for more practical systems like this.